Hello, my name is Phil. Today we're going to be deploying generative AI with RAG in ControlPlane.com, which is a multi-cloud platform. I'm going to be using this data camp tutorial, deploying N8N, Qdrant, and Ollama. The tutorial uses Docker, which is great. I'll put a link to this tutorial in the description. And of course, we're going to use the GPU version. So one reason to deploy in ControlPlane or the cloud is to take advantage of GPUs, right? If you don't have your own or can't afford one with enough VRAM to run LLMs locally. All right, so let's convert this Docker Compose file into a ControlPlane manifest. Okay. Yeah, so I've already downloaded this repo. Go ahead and into that, see what's in there. And what we're going to do is convert this Docker Compose file into a ControlPlane manifest. We're going to use cpln, and cpln is the command line utility for ControlPlane.com, and the directions to install it are pretty easy and available on docs.controlplane.com. So once you make your ControlPlane account, you'll enter some of that information to get cpln working with your account. Okay. So let's do cpln stack manifest and .chub. See the parameters there. So as long as there is a conventional docker-compose.yaml in the directory, it's just going to use that. If it's named unusually, it doesn't quite follow the convention, then you'll need to use the --compose file parameter. But let's go ahead and try this. And stack manifest. Okay, we get some errors. So let's take a look at this compose file. It is pretty interesting. You can see that it's using anchors and aliases, right? And then we'll alias these anchors, later in the services definitions. So this actually makes it easier for the user because you can use things like a profile and have multiple profiles in your Docker Compose instead of having multiple Docker Compose files. But we're going to go ahead and streamline this. And I've already streamlined this just to select the GPU profile and filled out the aliases. So let's go ahead and already go ahead and use this file and convert it to a ControlPlane manifest. Now I tried doing this like live editing and the video took like over an hour. We want to try to keep the video a little shorter than that. So let's try stack manifest against this file I've already prepared. Oops. All right. Stack cpln, stack manifest, and you need to use the compose file parameter. Since this is not a conventional Docker Compose file name. All right, you can see that works. Now I've already prepared some files, right, that are working, so I'll leave those alone, and they'll be in the GitHub that I'll make available later. Let's make a working. Actually, let's just put it out to a stack manifest. Well, I'll put it to a working. Working cpln compose.yaml. Okay, and then let's take a look at that. Working cpln compose. You see it's got it identifies the storage from the Docker Compose and converts the Docker Compose services into ControlPlane workloads. Okay, so we're going to streamline this even more. We're not going to be using the init containers. What this init container does, it actually imports a default kind of a basic workload, a demo workload, and we don't really need that. We'll just make our own. Okay, if you're running it in Docker Compose on your local machine, that's pretty cool. But we'll just make our own. So we're just gonna have the innate. Let's see. Oh, a note about Postgres. So you can use Postgres, but you can innate by default will use MySQL by itself. So we don't necessarily have to have the Postgres environment specified here. We don't need the Postgres workload necessarily. We are going to use Qdrant as the vector database, and we are going to use the ollama with the GPU workload, right? That's the whole point. But you notice that in this part of the definition, it doesn't specify a GPU, which we need, and we'll need an additional environment variable to make sure it uses the GPU. Right. So again, I've already prepared a version. What you would do is, edit this file to work in ControlPlane, and I've already done that. And I've called it genai.yaml. And what you can do is, as you can see here, I've already split it up into individual workloads in their volume set. When you're troubleshooting, it's nice to do this so you don't interfere with your other workloads. Yeah. All right, so I already set this one up, and I've prefixed the workload name with demo just to make it easier to filter from the web UI, which I will take a look at in a minute. Right, demo Qdrant. You notice that the resources have allocated more resources, and the default resources, right? If you look at working, that the stack manifest conversion will do is provides the minimum resources, right? 42 millicores, 128 megabytes. So what you do is as you deploy into ControlPlane actually provides Grafana metrics and logs, and you can see how much resources your workload is using and adjust your the resources in your definition accordingly. Also, if you're running it in Docker locally, you can use Docker stats and see how much resources it's actually using. So we've got here the N8N. This requires a little more CPU and memory. We're going to use these environment variables. Set up some storage. We're not going to be importing the demo workflow. All right, we'll just build our own. The Qdrant is pretty straightforward and doesn't use that many resources. You notice the ports and the ollama. Okay, so I'm going to talk about this a little bit. It does take more CPU. Remember, 6 full cores and 7 gigs of RAM. That's the minimum to run a GPU workload. And we'll see how that affects costs a little later. You do need to specify the GPU, and we're just going to use a T4, which has 16 gigs of VRAM. And we're just going to use one for this demo. And you do need to add this environment variable to make sure that the ollama uses the GPU. Okay, one thing I want to add is the N8N. N8N, the container doesn't use a root user container. Uses a node user, so you do need to add the security options right in the spec to make sure that it can access the storage. All right, great. I think we're ready to deploy now. All right, so yep, cpln apply -f genai.yaml, and you'll notice it looks very similar to Kubernetes YAML, right, for resources. But it's not directly Kubernetes YAML, right? It is control plane specific. But the syntax should be very familiar. And control plane does support Terraform and Pulumi if you want to automate your workloads a little more. All right, so let's apply -f genai.yaml, and okay, so I'm going to deploy this in, if you don't specify a GVC, it will deploy to whatever whatever you've set up as your default GVC, and you can see that in cpln profile get. All right, so my GVC, what's this? Is I'm using my work demo account, Inertial Labs, and my default GVC is Solo US East. So if I didn't specify the GVC, it would go to Solo US East. And just for the purpose of this demo, I'll go ahead and specify it anyway. C Solo US East. Okay, you'll note that it's creating the storage first, and then it creates the workloads. Okay, so let's go ahead and look at these workloads. Okay, so N8N already ready? And I've already got the workloads filtered for the demo workloading. All right, I'll give these a few minutes to start up, and I'll be back. Alrighty, the workloads are ready, so we can move on to the second part of the tutorial. The GPU workloads do take 12 to 15 minutes to get ready. Let's see. Okay, so we need to do some things on the Ollama container. So we'll go ahead and connect to this guy and detach. And run a few things here. Llama list. Yeah, let's go ahead and pull the model that we're going to use for the demo, Llama 3.2, and you can see in the original Docker Compose, they had an init container for the Ollama, which actually pulls the Llama 3.2 model. So you could try different models. The Ollama 3.2 model is 2 gigs. This GPU has 16 gigs of VRAM. Right, and then you can see Other models. Yeah, good models. Look at DeepSeek, which is hot right now. 7B is 4.7. That will definitely fit on the T4. You'd probably go up to 14B and work comfortably with that if you wanted to. But let's keep moving on. And we need ollama no big embed text. Okay, great. And then do ollama yes. On the list, you can see both those models are there. And we'll leave this just into ollama PS. So we'll see what happens when the model is actually loaded into the GPU. Okay, so we're done with that. Go to workloads. Now we're going to check the workflow. So we'll go to n8n. Info. We're going to use. We have a subdomain configured on this GVC. And the first thing that'll come up is setting up the admin user, right? So this is not your n8n login or anything like that. It's just your admin user for this instance. So I'm just going to use some use whatever you want here. Okay, skip all that, and we'll just start from scratch. Make the demo workflow that's included in the Docker compose from the tutorial. Okay, so we're just going to match what's here. We'll add a chat trigger. Fine. We're going to connect that to a basic LLM chain. Great. And we're going to connect that to a model, which is ollama chat model. And we're going to go ahead and create the credential. And we're going to use the internal name of our ollama workload. So if we look at our ollama workload, the first one up here is the internal name, which is the workload name dot the GVC and then cpln dot local. Right. So we'll go ahead and copy this and put that in place of the localhost. Okay, and we'll save. Connection successful. Great. Back to Canvas. And now we can test the chat. Right, so chat. Yeah. What's the color of grass? Okay, so we're watching the ollama PS, and you can see it loaded the model into the GPU, and you saw the gears spinning here, and the model comes up with an answer. Typically green, so that's fantastic. Great. Now a note, if you see here a CPU instead of GPU, go ahead and check your manifest and make sure that you have you have this env, CUDA visible devices, and index 0. Okay, so we can go next to that, and we won't need this anymore for the demo. All right, so let's move on. Now, time to create the AI workflow with RAG. Okay, so we'll create a new workflow. First step, chat trigger. Chat trigger, and here we're going to add the field, allow file uploads. Check yes. We'll hide the chat. Let's zoom out a bit. Add the Qdrant vector store. Qdrant vector store. Add documents to vector store. We're going to create a new credential, and here going to be the again, our internal name for our Qdrant workload. And it's going to be HTTP. Here we do need to add the port. I think it's 6333. Right. Yeah. The connection successful. Great. Oh. Then we'll go back to the demo. We insert documents by ID. Oh, Harry Potter. And all right, so here you could actually add the embedding of the document here. We'll just follow along with the tutorial. Connect the embedding. We're going to use embedding as ollama account, no make embed, text. Great. And connect the embedding model with a vector store. Did that. Oh, document loader with a vector store. Okay, so document loader, default document loader, type data binary, total input, data format. Okay, and then we're gonna add the text splitter, token splitter, chunk size 500, chunk overlap 50, canvas. Okay, that looks right. And now we're gonna test the Qdrant vector store. I've already downloaded these files. So we're gonna open the chat. And here, Harry Potter spells the. Okay, you can see everything splitting, creating the tokens. Great. Pretty nifty. Oh, we can go to the Qdrant store dashboard. Okay. So with ControlPlane, you're not going to specify the ports with the provided URLs at provided endpoints. So we'll go to Qdrant. Let's show it here. All right, just click the. Go and click our subdomain. Again, you need to just go use the path instead of the port. All right, and you can see that our Harry Potter dataset is in here. Great. I'll add the rest of the files to the vector store. And these will be Harry Potter movie data. Okay, so I've done this a few times already, and that dialog file actually takes the longest to tokenize. So I'll let this finish loading, and then I'll be back. All right, the tokenizer finished. It took 25 minutes. Now, I did make the mistake of refreshing the page and cause the execution to fail. So I cleaned out the previous data set. So, go here to the Qdrant and delete. This is actually fresh with a new run, and I recreated this workflow and uploaded the files again. I end up with 7,957 tokens in the Qdrant vector store. All right, so before we move on the last part of this tutorial, let's go ahead and look at some metrics. So let's look at, yeah, we'll look at all of them. Qdrant, metrics, N8N, metrics, and ollama metrics. Yeah, this is Qdrant. And I usually just look at CPU used and memory used. See if we need to increase resources, barely using any CPU. Oh, let's just look at the last 30 minutes. So we could probably reduce the resources on this. Peak just like 25% RAM. Okay, looks this is N8N, last 30 minutes. CPU not using that much. It is using some RAM, but not all of it. 60%, just over 60%. That's okay. And this is ollama. It's 30 minutes. And let's see, 30%. We're doing good. Alrighty. Last part of the tutorial. Okay. A little bit. Let's go ahead and add an AI agent. Agent type is conversational agent. Okay, we're good there. Oh, chat model, llama chat model, llama count. We use llama 3.2 latest. Model. Move this over here. Whoa. Okay, and this one looks like it automatically connected to both of them. We're just going to delete that connection for now. At the store tool with the AI agent. Let's look down at what the end goal is here. Okay, going to connect vector store tool. And data file name is the input file. Description, knowledge base is used to answer questions related to Harry Potter movies. And we're going to connect it to the vector store. Vector store. True documents for agent chain by ID. Here we'll put Harry Potter. Embedding, ollama embeddings, ollama account, notebook embed text to canvas. Tool, embedding model, and we need to add the ollama chat model. Here. Chat model, ollama account, 3.2 latest, to canvas. We're set. All right, time to test the workflow. Okay, so we're going to ask a question. What is the most great place in Hogwarts? All right. See if it goes to the vector store. Okay, to go to the vector store, back to the chat model. And location of the most secret place itself remains unknown. Okay. Let's try the next one. Is most powerful spell. It is hitting the vector store. Most powerful spells in Harry Potter in the situation include Avocadra, Imperio, and Crucio. Okay. So that is interesting. So it will be fun to test with your own data. I enjoy setting this up. So we have gone through converting an interesting Docker Compose file into a ControlPlane manifest, which we deployed in ControlPlane. We accessed the endpoints and ran through a workload, including a GPU deployment. So go ahead and try this out, if not just a Docker file. Let's talk about the cost a little bit. Just a quick insert here. Let's go ahead and clean up our workloads. And we can do that easily, right? So we got storage volumes and workloads, and we want to do that as quickly as possible. So we're going to use the same syntax for the apply command and just do delete. Very similar to Kubernetes kubectl commands, right? That deletes the workloads, then the volume sets. Let's go ahead and refresh. Workloads are gone. So the demo volume sets are gone. And we are good. So ControlPlane has this nice calculator, price calculator. So let's go through our workloads and see how much it would actually cost. So for N8N, let's see, had 400 millicores, CPU, memory 512 megabytes. So that would be in volumes 10. We only gave that 10 gigs of storage. Right, and don't worry about egress too much here. Monthly, $30 a month. How about for a day? $1. How about for an hour? 4 cents. So that's pretty cool. All right, let's check Qdrant. It's 150 millicores and 200 fix, 6 megabytes. So I think hourly, daily, 40 cents, weekly, $3, monthly, $13. Okay, and then ollama, this is the big one. We're going to do full cores, 6 cores, gigs of RAM, 7. Okay, and this one we did give 100 gigs of storage, I think. Yeah. Okay, so that's 444 monthly. And that's actually on par with the other providers for a GPU workload. So Pico, let's see, daily, it's $14, hourly, 60 cents, right? So used it for, 4 hours, it's $2.40. So I think it's reasonable, and you can determine if it's reasonable for you. Right, so if you actually want some help getting your workloads into ControlPlane, you can hit up inertialabs.io or contact ControlPlane and set up an account and try it out. All right, thanks for watching. Have a great day.